Good morning to you all. I'd like to talk to you today about front-end programming, essentially making user interfaces using programming. And I thought I'd start right at the very basics and ask the question, how do you actually build a user interface? And in almost all cases, it's just a matter of an event loop and a tree structure of components. So you have the tree and you have the loop around the tree there. This has been going on since essentially forever, since the very, very first graphical user interfaces. I used to program on this thing. I think we didn't have tree structures yet. I think this was essentially just a list of components to be rendered, and there was no real concept of stacking except inside Windows. We moved on a bit though. This is a more modern and more traditionally desktop-oriented user interface library called Qt. And it's designer tool. You can see the tree structure now. You got like the window on top, and you got like various boxes to compose subcomponents, and then eventually you got a couple of buttons at the bottom there. And this isn't really what most of us tend to do for user interfaces nowadays, though, because we got this thing called the internet. So we are seeing most applications that we use nowadays have sort of migrated into the browser. Mostly we use them to find pictures of cats with their tongues out, preferably. I like them that way. But, you know, there are different applications too, like applications that enable us to shout at each other when we get mad. But the thing that these applications are composed out of is called a document object model. Now, I struggle a bit to find an appropriate illustration for the DOM and how I feel about it. Fortunately, the art of Hieronymus Bosch finally delivered. The DOM, well, I'm going to be polite and say it's an interesting thing. It's very, very, very object-oriented. It came about in the essentially the golden age of Java in the mid-90s, and in fact, the language that it was sort of written to be used by is called JavaScript, because it's not really got anything to do with Java. It was just that when it was developed at Netscape, Java was very cool, and Netscape was hoping to make a deal with the Sun about Java, so they decided we got to call this JavaScript so people think it's related. And the syntax was changed to sort of look to adopt the C tradition and the current state of the Java syntax. And it's really a massive mutable state. It's very much adopted Java's idea of object orientation. So you got every component encapsulates its own state. That state is very much up in the air what it is at any given time. And, well, we would very much like to do UI development in a functional style, and that doesn't really translate well. The DOM is, I would venture to say it's largely incompatible with thinking in a traditional functional style, because the ideal of functional programming is that all your code should be pure. Now, we don't actually accomplish this normally, because if all your code is pure, it has no side effects, and so it only generates heat, as Simon Jones likes to say. You know, we get pragmatic, but we want to ensure that as much of our code as possible is actually pure and has no side effects, so we can reason about it a lot more easily. And code which manipulates mutable state is rather the opposite of that. If you spend all your time changing the state of DOM objects, then you're not being very pure. Which is why we have been exploring ways to mitigate this. We have this thing now called React, which Facebook launched a couple of years ago now. This illustration is I think, another sort of React. And React introduces the virtual DOM. The idea of the virtual DOM is that we create a data structure in our functional programs, which is completely immutable, And when we're done doing this in our event loop, we just pass it on to React, and React does all the if bits of syncing that data structure up with the actual DOM, so that we can manipulate data structures. So that we can manipulate the DOM, pretending that it's actually an immutable, properly pure data structure. It isolates mutation essentially to the rendering phase, so that everything in between your input events and your actual output to the DOM can be theoretically pure functional programming, except that it doesn't really. React is cool and all, but it still uses JavaScript's mutable data structures. It still mutates state inside components. It's a lot cleaner now than it used to be, but it's still not quite there. So, yeah. What I just said, it's still neatly managed, but still not quite where we want to be functionally. So there was this fellow called David Nolan who had this idea that what if we took React and we sort of took out the mutable bits and replaced them with Clojure's immutable data structures, and essentially Clojure's way of thinking about writing application. Clojure script in particular, of course. So is the framework that I came up with. Ohm does not have a logo, so I took the liberty of making one for them. I hope they appreciate it. Essentially, Ohm is React with the Clojure philosophy applied. So that means we got all immutable data structures, a guarantee of having just immutable data structures because you're using Clojure scripts libraries for them. And in ClojureScript, you have to actually struggle a bit to use JavaScript's normal mutable structures. It's not entirely pure, but as with Clojure itself, it provides a sensible effort. It's idiomatic that you write pure code until you can't anymore, and then at the very least you mark your functions with a bang at the end saying, this function will have side effects, please don't use it unless you really mean it. So, yeah. I meant to say a bit more about Elm An ClojureScript actually before I move on to the next thing. It has some interesting features. I don't think I'm going to have time to talk about them, so I took the slides out. But it does things like cursors, which help compose subcomponents. Cursors are sort of like lenses, not entirely. But it remains a Clojure application, essentially. And with Clojure, you do sort of mutate state at some point. Sort of very clean and immutable normally, but you usually end up having your application state hidden away in an atom. And that is sort of global mutable states. Yeah. I'm just going to move on to Elm. Elm is interesting, though. We're getting somewhere, I think. Elm is, I said it's an elegant UI specialized Haskell cousin. It looks a lot like Haskell, except if you take all the messy part of Haskell out, and all the complicated bits, essentially, like the M word and whatnot, and you're left with this very, very clean language that, for one thing, it's very easy to learn, it's very easy to teach, and that's been a design goal of Elm. And there's no unnecessary category theory. I couldn't point to data suggesting this, but I have a feeling that you can take a JavaScript developer and sit them down and show them Elm, and within a couple of days they're going to be completely productive in a language that is considerably safer to use than JavaScript. Given you have a type system, it's not quite as advanced as Haskell's, but it's definitely close enough. And you have enforced purity. There are almost no side effects in Elm. And in your Elm programs, at least, of course, there have to be side effects. It's a very nice language. And I'd like to discuss the application architecture that is normally used in Elm for a little bit. Essentially, it's started with a model which models your data, your application state. You got some events which can affect that state, and you got an update function to process those, and you got a view right at the end, which essentially takes a model and turns it into an HTML document and renders it on screen. Using the same principles as React, the HTML type that you can see at the bottom there is represents an HTML document in a virtual DOM style data structure. And Anne would just take care of that for you, put it in the actual DOM, fetch events out of the DOM, and put them back into your system. This is based on functional reactive programming. Or at least, functional reactive programming is a thing that was formulated by somebody at Microsoft Research in 97 or thereabouts. And we had a lot of iterations on the idea, but functional reactive programming as a term, I don't think we're allowed to use that on anything except the original implementation. And in any case, at least I think, because nobody can quite agree on the definition here, that Elm's implementation is probably as close to FRP as you can get using JavaScript, but it gets only like 99% there. In any case, Elm is at least very close to the original intention, and it looks sort of like this. Essentially, you have a signal type, and the signal is a value that changes over time. So it has an initial value, and then at certain points it will change that value, and you can react to that when it happens. So you have things like mouse position, which is the signal which contains the corner path. You have mouse buttons, which are just Boolean saying whether they are clicked or not. You can have a time signal, which just counts upwards at regular intervals, and so on. And usually, your input signals will be responses from the user to your application. And you can take the signals, you can map over them, treat them like functors. You can fold over them. The fold P here is slightly interesting. It looks exactly like a fold, except it yields intermediate results. So it's not a catamorphism. It doesn't compress everything into a single result. It yields the intermediate result. So you can use it to manage your application state, essentially. You start with an initial state, and then you feed events into your fold, and it updates the state for you, and yielding intermediate states. So an Elm application will look something like this. It's really just a signal of HTML documents. And you have a model, which is a signal which contains your model. And you have a view function, which takes your model and turns the model into an HTML document when it changes. And then you sort of tie the loop with the actions. And you have the signal mailbox and signal address things there, which I'm not going to bother with the details of those, but essentially you can, from inside your HTML document, you can feed actions back into the main loop. So you start over again, and these actions will alter your model potentially, and we go around. And it's a very, very neat and clean model. It's like just a pipeline, essentially, that is expressed by very few functions. So I drew your diagram, just to recap. You have the DOM, which is something you don't want to deal with, and which Elm masks very neatly for you. The DOM can generate actions. Actions will affect your model. When your model changes, it will affect the view. And when the view changes, it gets fed back into the DOM. And that's your application, essentially. That's your user interface, at least. The problem here is composition. It gets a bit boilerplatey when you want to make subcomponents out of this, because you will want to have reusable components. You can't just put everything in your entire application, which can get quite big, into just one update function and one render function. But you want to reuse them. You want to have like button components and so on that you can just put in anywhere. But tying the knot there it gets not complicated, definitely not, but it gets a bit boilerplatey, because you have to make sure that you handle passing all the events down to the subcomponents, getting them back, putting them where they're supposed to be, and so on. It's not entirely as neat as I'd like it to be, but research is ongoing, of course, and I expect by the next version of Elm there's going to be like a perfect solution. Right now you have to do a bit of boilerplate, which is unfortunate. Now I'd like to talk about PureScript. PureScript is a better Haskell than Haskell, I'd like to say. It's a very, very bold statement. But my argument here is that it sort of learned from the mistakes of Haskell and has started out with a clean slate and avoiding the more obvious things. Like, it goes, actually, Haskell, I think you did that functor monad thing wrong. There should be an applicative in there somewhere, and so on. It's just, Haskell's grown so big now, the thing they hope to avoid, that it's hard to change things. They still do it, fortunately, but with a thing like PureScript, which has, I think, probably, if it's got 100 users, I'd be surprised. It's a lot easier to break things, and they do it all the time. We just had a release a couple of days ago, which broke literally everything. I'm using the previous version for this presentation, or I wouldn't be able to do it. It cares about types even more than Haskell does. That's a bold statement too. I'd like to say at least it cares a lot more about types than Elm does. Elm aims to be simple and understandable for mortals, whereas PureScript likes to go all out in the category theory and 5-line type signatures and all that, just because at least it ensures absolute correctness, doesn't it? Or at least we like to think so. What I'm going to be doing for the rest of this talk is show you PureScript Halogen, which is the UI library that is sort of heading towards dominance in PureScript. It's based essentially on the same principles as Elm, except it goes somewhat further. The application in Elm looks essentially like this. It's a signal that yields HTML documents, whereas we would like to enrich that with an event type so that we can essentially ensure that we know what sort of events will come out of the HTML document. Further, we take that and we actually split it up into a signal of input events to a signal of outputs. In this case, the event type is similar, which is what you normally see at the top level. Taking that a step further, we can actually generalize this a bit as what this is sort of a signal function, a function that will take one signal and yield another, essentially mapping on it. And we call that SF, signal function, which takes an input event and a document yielding output events. The implementation of signal functions looks like this. In practice, you won't see them diverge much in functionality from Elm signals when you use folds, but what these essentially are, you can do almost anything with this. They're sort of not finite state machines, but infinite state machines. You can change the behavior of the signal in midstream, sort of. But it remains a signal function from input to output. And what's exciting about that is these actually form profunctors too, which means that ideally you can do a lot of interesting things in the way of composition between components and subcomponents. Given that they are profunctors, you can sort of diamap from the supercomponent to the subcomponent and back. At least that's the theory of it. What you end up doing for the most part is you just do exactly like in Elm. The stateful function is essentially the fold P from Elm. And it takes an initial state, it takes a fold function which processes your inputs, and it generates a signal function of output state. Just one more thing I would like to do to this before I'm quite satisfied. I'm going to introduce the M into this type. Essentially, we put the M right before the output event there, because obviously everything's better with a monad in it. So the reason we put a monad right there at the end is because you might want actions to cause asynchronous actions. So you can have something like an IO monad to go and fetch something and produce an action out of that. And that yields something that we can start building applications with. We take these signal functions and we make a component out of them. A component clarifies this. We still have the am, because we got to add the am. And you got a request and a result, which is essentially the input type and the output type. So we're clarifying that the input and the output types can be separate and will be with subcomponents. So that leads to the question, how do I compose components? Look at the puppy. Look at the puppy. The puppy is adorable. The puppy is playing in the snow. Don't think about the question. The problem is, it turns out that even though the ideas behind these were very ambitious, the current implementation actually doesn't improve on Elm at all. It still gets very complicated. You get to use pro-functors, which makes it feel slightly smarter, but that's about it. Still gets very messy. And I've been promised, actually I was really hoping to be able to show you how this would work today, but I've been promised it's going to be ready by next week. So we'll see. I am at least going to show you how to write an application. Have I actually got 20 minutes left? Wow. I didn't expect that. I'm going to have ample time to write this then. Because I'm going to switch to some live coding now because watching me talk is rather boring, I'm sure. I'm going to write an application for you using Halogen, so you can see sort of how it works in practice. Because I can talk about category theory all day, but it doesn't really map to the real world unless you see it, I think. So an application in Halogen usually looks like this. The main function just runs one component, which we call UI. And the run UI function takes this component and initializes it, starts it going. And it returns the DOM node that it's going to be rendered in, and a driver function. The driver function allows you to feed events in externally, but we're not going to be using that. The node, though, we essentially just take that and put it inside the HTML document. So let's get coding. There is quite a number of imports, which I've written for you already. You don't want to watch me type this out. I got the append to body function, which just takes a DOM node and puts it in the HTML document. And then I've written a very basic boilerplate app here, which just renders a document, has no state. I'm just defining an ADT here to contain the state, and you'll notice it has none. And I'm defining another ADT here to contain our events. Right now we just have the nope event, which we don't care about. And this is the UI component. It essentially takes a stateful signal with an initial state of the empty list state and maps it over the update function and maps all that over the render function. So the update function does nothing currently. Just returns the state as you pass it in. Doesn't care about the event. And the render function just outputs this document here in the sort of DSL for HTML. So what this one means is this is a div element. With the underscore, it says it won't take any arguments. It won't take any HTML arguments. Without the underscore, as in the image here, we can pass a list of arguments. Otherwise, we just pass a list of children. In this case, we have arguments and children, but there are none. So this should get us started. Let's see if this compiles. Takes a couple of seconds. Just a little type checking and a lot of dependencies. There we go. So we've got this framework to build on. I hope you like ponies, by the way, because we're going to be doing a few of them. So I'd like to just write a very simple application which lets you make a list of ponies. A list of your favorite ponies, presumably. So to start off, I'm going to take away this very obvious statement here and replace it with a list. The UL of taking the render pony function and mapping it over a list of ponies. Now we need to actually get our types in order before we go that far. So we're going to start with the most crucial thing. We make a pony type. It'll just be a string, which will contain the name of the pony. And for our state now, we want a list of ponies. And we have to add this to use Haskell's lovely style of indenting lists here. So let's start off with Applejack and Fluttershy. If you've got a favourite pony, I might consider adding them. Rarity? Just start off with the ponies with only one word in their names. So we need to actually now get the list of ponies out of our state in our render function. And thank you for shutting that. And we need the render pony function. Takes a pony and returns HTML. Takes a pony P and returns a list item of the text inside the pony. So I wonder if that's enough. You're all conversant in Haskell, yes? Did you see me make any mistakes? Because if I do, I am absolutely blaming you. Let's see. Fingers crossed. No, it worked. There's our list. Yay. Now, I'd like to add some more ponies interactively. So I'm going to need to enrich my state a little bit. I want an input field, essentially. And the application needs to track the contents of the input field. So I'm going to add one more thing to our state. I'm going to add just one pony, which is going to be just the string that represents what you've typed so far. And I'm going to need to add some events. First of all, so the way I'm going to make this work now is I'm going to have just a new pony event, which does not contain the name of the pony, because we're going to make this as a form, and the input field inside the form is going to be tracked in pony, and when it changes, we want to fire entry updated, which contains the pony, which goes into our state. And when you then fire a new pony by submitting the form, we don't have any easy way to access the input field, so we're going to have to rely on what our state claims it to be. So a new pony will take this pony and put it inside the list of ponies. First, then, let us add the form. And we're going to add an event handler for that. The onSubmit property is good for that. It's going to be a function which gets an event. Don't care about the event, but we're going to prevent defaults on it, so it doesn't actually reload the page, because we don't have any database backing here. So if we just reload the page, all our ponies are going to vanish. And after that, we're going to turn a new pony event. Okay, and inside the form, we're going to have an input, which is going to be of type underscore text, and value of entry, which I need to get out of our state entry. This is the pony at the end. And on value changed, god damn it, there we go. Okay. Whenever the value changes inside the input, we're going to yield an input event, and this input property takes a function which will get the new value as an argument, and that function is just going to be our type instructor for entry updated. So that's going to generate an entry updated event which contains what you've typed currently. Let me just see, balance all these horrible things. And no children, and there we go. Alright. So I think we're good up here. Oh no. We also need to add that extra pony to our initial state. It's just going to start off as an empty string, because your input field is going to be empty at first. See if that compiles. I'm assured that the newest release of the compiler is a lot faster. So I can type, say, rainbow dash, and yeah, nothing happens. Actually, something does happen. All my events get fired, but I don't respond to them in the update function. So when I hit enter here, I will get an update of the UI, but the entry field in our state hasn't been updated, so it just returns to the empty string, which it thinks it is. So we're going to need to add some events here. So let's get ponies out of this one. This update function takes the state, the current state, and the event to be processed. So I pattern match and get the ponies out of the state. Well, I'm going to process entry updated, which provides a new value for the entry. So I don't care about what it currently is. And I return a new state, which contains our ponies and the new entry. And then I want to add new ponies. So I'm going to handle the new pony event. In this case, we want the ponies and we want the current state of the entry books. And new pony equals this state of, I'm going to keep them sorted. Be very clean about that. And then I'll just take the current pony and const it onto the rest of the ponies. And what should I make the state of the input box here? Empty string. Because now I'm done entering. I want to reset it so I can enter more ponies, because you can never have enough ponies. Let's see if that works. Okay, rainbow dash. Cool. Twilight sparkle. Very cool. And Pinkie Pie. Oops, I mistyped it. So I'd like to be able to delete that and add it properly. So let's see if we can do that. Just going to add one more event. Let's call it remove pony, and the name of the pony to be removed. And then going to add to the render pony function, actually, because I want a button next to each pony that I can click to delete it. So I'm going to add a button, and the button is going to have an on-click handler, which generates an input event, remove pony of the current P, and it's going to have text in it, and I'm going to get really fancy. I actually discovered while writing this talk that PureScript string type, string literal, doesn't handle Unicode. And I want a nice Unicode cross there, so I'm going to get really fancy. Character dot from character code. 10,007. Okay. So let's see if that works or not. Yes, we have a button. Doesn't do anything yet, though. I have to update the update function. So list state ponies entry remove pony. I'm only getting the entry out here now because I want to preserve it. I'm not going to use it. The pony that comes in through the event is the one I want to delete. And I just go delete ponies. Delete is a function in the array library, which takes pony out of the ponies array, and the current entry. So now I can go, hopefully, if this compiles, I can start deleting things. So rainbow dash, twilight, sparkle, Pinkie, mistyped pie. Then I can delete Pinkie. It works. And I can type it in properly. Pinkie Pie. Right. That was the whole application. You might want to plug in a database and all that to make sure you don't lose any ponies. Oh, yeah. like to add Larry Ellison at the end in a nice way. Well, that was halogen, ladies and gentlemen, and some nice ponies at the end of the day. That's my final slide. So thank you very much. I believe we can do some questions if you have some. If you can concentrate on watching that thing.
When you map the model to the DOM, are you? Am I right in understanding that you are replacing the whole DOM object with an entirely new one? And if so, is that expensive?
That would be insane, yeah, because there's nothing, I think, in the history of programming that is quite as slow as modifying the DOM. So what's happening there? This was React's great innovation. It does a diff from what it currently is and what it's expected to be, or rather what it used to be previously for performance reason, and what it needs to be. So it will generate, the diffing algorithm will generate a minimal set of changes needed to take the DOM from its current state to the state you want it to be in, which is remarkably more efficient, actually usually more efficient than writing it by hand. So that's what's going on there.
Do you think dependent types or some light form of dependent types could help with the composition or the modularity?
I haven't actually given that much thought. I would assume that because obviously dependent types can do absolutely anything better, that there might be something there. Now the problem is that PureScript doesn't have dependent types, neither does Elm, and I would suspect that Elm really doesn't want to have them.
But for example, Haskell has the type promotion, and I saw, say, for a sort of extensible pattern matching that, or type-safe extensible pattern matching, they use that. Or?
I'm sure there's something in there. And what I'd really like to see is, because Idris has a JS backend, I would like to see someone to do this in Idris and see how much better it gets.
Okay.
But currently, I don't have any research to show you on that.
Is it really necessary to type all those types, or is it just like limitation of the compiler?
Well, Philip Wadler did tell me that you should type all the types to make sure that you get the program you expect. But of course, PureScript does type inference to some extent, just as Haskell does. Sometimes you have to type them out because you get the wrong types inferred, but you know, this is the world we live in essentially in Haskell as well.
Okay, and related question: do you have like any problems with performance of PureScript, or is it just? I mean, is it works in practice?
Yeah, it compiles down to very neat JavaScript, very close to the PureScript, except of course for the types. So yeah, there is, I suppose, a very marginal performances because PureScript is a current language. So the sort of code that it generates actually is JavaScript functions which don't take several arguments but will take one argument, returning a function, taking the next argument, and so on. So there are more function calls in PureScript code than in JavaScript, but mostly it's entirely on par with JavaScript.
As you said, as you already shown with Clojure, and the same thing applies to Elm, when you need to add some new features, usually you add a new action and the code that processes it via inside the update, right? And this is actually seems like a problem for me because you are forced to have only these actions, and this is okay when you are when you are working on the complete application, but it's not really acceptable when you are working on some components. What are the actual solution for this?
Well, I mentioned that because the component type.
No. How would it actually look like?
How would it look
in theory, at least?
Well, the sad answer for halogen is we don't really know yet. We're hoping to see it next week. In Elm, it essentially looks like a series of functions that just do the mapping for you. So you subcomponents will be isolated. They will have their own event types.
But you need to know which component to set send which event.
Yes, you do, and that's the boilerplate I was complaining about. We don't have a solution there yet.
Okay, thank
But
you.
I know the halogen guys are thinking very hard about it, and I would be very surprised if the Elm guys don't already have a solution planned.
Thank you.
Last question. Okay, thank you.
Thank you. Oh yeah, final note. My slides are right there on that URL if you want to check them out.